Thank you, everyone, for coming here today. Also, for those attending from remote positions online. Today, we're going to have an open day explaining our PhD program in aerospace science and technology, aerospace engineering. And this is Manuel Soler, director of the program. Here you have my email should you want to contact me. Basically, well, I welcome you all to this building. The first day in Spain without masks, apparently, but we all are wearing masks. Well, we're going to have hopefully short description of the PhD program. This open day is intended for those master students or even professionals that would like to pursue a PhD, to study a PhD program with us. So we will be describing a little bit the PhD program, students, supervisors, activities, practical information, scholarships. And then after that, we'll go into explaining the different research lines that we have in the department and some possibilities, some openings, PhD opportunities that the different researchers are going to offer that are now offering opportunities or will be appearing in fall 2022 or even in 2023. We will have discussion at the end, but last but not least, hopefully at 2:15, we'll have some snacks, beer, and we will have the opportunity to talk, to meet the supervisors, and to have lunch together. All right. So basically, the mission of the PhD is to train students after a master's or master level students to do research, groundbreaking research, to reshape the frontiers of knowledge, in this case in areas related to aerospace, science and technology. We're going to provide you with technical and scientific competencies, can be theoretical, numerical or experimental. And the environment in which you're going to be developing your PhD is highly international, intersectorial, in the sense that we have academia, the university, we have industries, and also research institutes. And also, of course, multidisciplinary, because most of us are aerospace engineers, but we have also people coming from the mechanical engineering domain, physics, mathematics, communication engineering or electrical engineering, etc. And what are the career opportunities once you finish your PhD? Well, mainly three. To follow a scientific career, mainly at universities or research centers. It can be in Spain, can be outside, in the United States, in Europe. We have, for instance, some people at MIT, University of San Diego, and other places. Also in Spain, there has been a lot of programs in Spain, aerospace engineering degrees, bachelors, masters, and they need faculty people that are trained. That's one possibility. Another one is to follow a professional career in the aerospace R&D industry. Both space and aeronautics are demanding more and more high-skilled people, right? And we have there is demand, so that you, after finishing the PhD, you can jump into an R&D department at DMV, Deimos, Airbus, or other stakeholders. And we have also some examples. And last but not least, after finalizing your PhD, it's very interesting to try to create a spin-off or startup company. And that's very important, and we have also one example, Aerospace. Some students, former students of the department, that have created a spin-off, and now they are working with us in industrial doctorates. So this is another opportunity. After developing an algorithm or a solution or a software, you can ambition to do that if you are well connected. So these are the main three opportunities for you. Briefly speaking, we have two areas, as you might imagine, space and aeronautics, so atmospheric flight. And we conduct research in different areas. I am not going to go into detail because the different members of the faculty will explain in more detail, but we have, of course, topics related to structures and materials, manufacturing, aircraft design, including hydrogen electric aircraft, aerodynamics, numerical and experimental aerodynamics, propulsion, aircraft operations. Also, when it comes to space, we have electric propulsion for space systems or space ships, astrodynamics, control, both for space and aeronautics, and space systems, such as, for instance, tethers. You will hear more about this. And now let's focus on the PhD students. We have 41 PhD students. You can see just 8 of them. If you click in the website, you can access each of the profiles and check the title, abstract, supervisor, even some presentations they have done, projects in which they are involved, etc. Right? I was saying that you would be working in an international environment, and you can see that half of our PhD students are Spanish, but we have also Italian people, 10 Italian students, people from Iran, from France, Norway, China, and in the end, we are highly international. We are collaborating with many entities, and we invite international students to come and visit us and do a PhD with us as well. When it comes to gender, this is still not very well balanced. We have just 6 women. We are seeking for more women to conduct research careers in aerospace. So it's true that this world aviation is clearly unbalanced today, and we need to make an effort to close this gap. So I invite women to contact us and do a PhD with us. And when it comes to sectors, most of the PhDs are academic, so to speak, so people that is hired at the university doing a research under a project, but at the university under the supervision of someone, probably teaching some lectures, but not necessarily. We have 7 industrial PhDs, so people that is working at a company while doing a PhD, aligned with what they do at work, right? They are mainly linked to the space area, right? Meaning that in Spain, probably, in space, sorry, they are more willing to do PhDs, or they have more skilled people today, and we also need to close that gap when it comes to aeronautics. So I invite people working in aeronautical domain to start thinking on doing an industrial PhD as well. And when it comes to institutional cooperation, here we're talking about people that might be working in research centers, such as INTA, for instance, ESA, the Army, or others, right? And they, of course, need a university that could provide a title, and we can have this collaboration, so we also invite these people to try to do a PhD with us in cooperation with the research center. We will be discussing a bit more on this later on. When it comes to supervisors, we have a total of 21 supervisors, most of them of the Aerospace department. You just see 3 of them, Eduardo Edo, our professor, and 2 other professors from electrical engineering departments, electronics and signal theory. And if you click here, you could see myself and other colleagues as supervisors, all right? When it comes to projects, we are involved in many high-level projects. We have 2 ERCs, FET Open project, Marie Curie's, projects within CESAR. Those are European projects, so we are collaborating with international entities at a very high level. We have quite a few national projects and also regional ones. So we are well connected at the European level, at the national level, and at regional level, and we have also connections with people working at the United States and in other places. You can see a complete list of projects in which the PhD students are working or conducting research within the umbrella of those projects while doing a PhD, okay? That's the idea. As for activities we are organizing, probably you cannot see, but we are trying to organize seminars roughly once per month, And we had Stefano and Mario, our two ERCs, starting grant, opening this series. We had invited Ignacio Viola, Javier Jimenez, and other people to come and give a talk, meet us, not only us, but also you as PhD students, to foster collaborations. And what's coming up? We're having 4 seminars kind of packed in 2 weeks, including Andrea Gianelli, a former student of Andres, that is now working at ETH. Isabel, one of the few females, full professor females in the aerospace domain in Spain. I think we have 3. So we have invited her. Thomas Ott is working at Airbus and co-supervising one of the theses. And we have Massimiliano Zanin from CSIC. He has a starting grant ERC, and he will come in May. So stay tuned. We always broadcast the seminars via our media, record them, and post the videos. But you can also come here, get to talk with the researchers, and you can follow LinkedIn and Twitter, in which we are very active in promoting these things. Attending to the seminars is quite important because you get scientific culture, and you get exposed to what other people is doing. Sometimes you think, imagine, no, what someone else is doing in a complete different field doesn't matter, but indeed, all of us are doing science. And scientific research shares always the same basis. So it's very important to be exposed to other cultures, other research topics, other nationalities, other genders, other sectors. This is what we are doing here. Another activity that we are organizing is what we call PhD doctoral meetings. We had the first edition last June. It was unfortunately online, purely remote, but everything was recorded, and the PhD students presented in 10 minutes their progress. The first year can be just the state of the art, what are the motivation, the goals, the challenges, and then little by little you would be presenting your scientific results and how you are contributing beyond the state of the art and reshaping the frontiers of knowledge. This year, the doctoral meetings will be here in this room. We will also have some snacks, beers, and it will be something that we could share, not only the presentations, but also the coffees, lunch, and it will take place in these 2 days. So please annotate the date, especially the PhD students, because you will have to be here, and not me, and share your progress with the audience. So I think that's good. And another important activity is to do research stays. Pretty much maybe bachelor, master students that did Erasmus, and this is an amazing experience, vital experience, I would say. Doing research stays while doing a PhD is similar. You go 3 to 6 months abroad, you get exposed to a different environment of work with different people, and you get to learn a lot. You start up your collaborations that you might carry on for years in your career. And we have here some examples. As you might imagine, this has been blocked due to COVID, but we are starting to travel, and we have people at TU Delft, ESA, Los Alamos at the United States, Lausanne, Padova, and others that are not here, okay? And this is important to strengthen our international network of collaborations. Of course, one important activity for a PhD is to publish, right? We must publish, we must communicate our scientific achievements in conferences, but also in scientific journal papers. And here, this is the list of the 2022 papers, 3 months. And if you go to the web, you can see the complete list of publications. We try to broadcast the publications so that the impact is maximized, and also the potential follow-up of a publication in terms of a collaboration, a project, or whatever. So practical information. Maybe you are wondering, what do you need to do a PhD with us? Well, if you hold a bachelor and 60 credits of a master, and in total 300 credits, you are eligible and you can be enrolled in our program. This is the administrative requirement. So first year students at the master, that have already passed 60 credits could start thinking on enrolling with us. Prefer background in space engineering? Yes, but we are highly interested in multidisciplinarity. So people coming from physics, mathematical domain, other fields of engineering are quite welcome, because in the end, we are doing PhD topics that are highly multidisciplinary. And sometimes we need a mathematical insight, or we need physicists to do some laboratory studies, or we need software, hardware engineers, or we need to combine structures with signals and with aeronautics, I don't know, right? So what do you need to be admitted? So sometimes people start with the paperwork. No. Paperwork, you don't need to start with the paperwork. Avoid paperwork as much as possible. You need to think strategic, okay? So a PhD is something that you need to prepare. First of all, you need to find a supervisor. Without a supervisor, you cannot get into our PhD program. So you were seeing the list of supervisors. You need to check who is doing what is your field of interest, and get in touch with him or her to find a topic and a research line and a commitment for the supervision. Supervision is not for free. It implies a commitment by us with you. So this is important, right? So first thing you need to do. Second, you need to get paid, right? Because you are a grown up and you need to at least live. So you need to get a scholarship or a contract. So it can be it can be that a researcher has got a project and is offering a position linked to that project, a direct contract. It would be like finding a job. Or it can be that you have interest for a topic, you feel good with a potential supervisor, you discuss a potential topic, and you try to go together and find scholarship opportunities, right? When it comes to a PhD, you need to go together with your supervisor. And there are some options at the national level, the so-called FPU. Last year, we got 4 out of 15 scholarships in the mechanical, naval, and aerospace domain. This year, the opening is already closed, but it will open again in October. This is for people with very high marks, higher than 80% out of 80 out of 100. So if you have such a mark, you would be eligible most likely for the program. Then there is another option with La Caixa scholarships that were closing in February this year, but they will open again. And similarly, you need to apply and see if you can find money for your PhD. There are also options at the CAMP, Comunidad de Madrid region. And there might be others, especially if you are living outside Spain, you might have your own programs in Italy, Germany, wherever. And there might be others we are not aware of, all right? So finding the money is also important. Once you have the supervisor, once you have the money, then just fill the paperwork. And you can get in touch with me, and we can do that, which is easy, right? But first of all, think strategically, think 1 year ahead of time. This is the reason because we are here today. What are the PhD requirements? So what do you need to do to actually file your thesis and defend it here? Well, you must publish at least one high-impact journal paper, at least one. Even if you are doing an industrial PhD, we must publish, we must go beyond the state of the art, and we must be evaluated by independent and blind reviewers. You have to participate in the doctoral meetings every year, one presentation per year, and you have to at least deliver one presentation in a conference. These are the requirements. On top of that, if you want to have this international mention, you must go 3 months abroad and visit some institution, which I fully recommend, but it's not a must. It is recommended to attend seminars and to get involved into the dynamics of the department. And the transversal credits kind of deliver a good presentation, write a nice piece of work, entrepreneurship, and all the things that the School of Doctorate is offering, those are optional. Of course, if you are interested in starting up a company, you might be interested in some of the courses they are offering. If your communication skills are not good, together with the supervisor, you might want to attend one of those courses on delivering good presentations, etc. Now, let's go into the research lines and PhD positions that we're going to be offering during the next months, next 1-2 years. I'm going to deliver some of these, inviting some people to come here. So I'll try to do my best. Stefan, Andrea, well, I mean, you had some notes here, but I cannot even read. If you want to come, these guys are doing experimental aerodynamics. I don't know if you can talk and...
Yeah, sure. Okay, so thanks, Manuel, by the way, for setting up this very nice event. So one of the research lines of the PhD, we have already 3 students involved in the program, is on experimental aerodynamics and propulsion. What we do is basically developing onto 2 main lines. One is development and application of measurement techniques. We are one of the few groups in Europe working on the development on volumetric particle image velocimetry. I will not explain that in too much detail, but basically it's a technique which measures 3-dimensional velocity fields using lasers and seeding particles. Here you can see at the bottom left a nice example of tomographic PFV measurement that Andrea Niro carried out in collaboration with TU Delft at the TU Delft facilities. This line is funded by an ERC starting grant. The Next Flow project, you can click on the web page there and check a bit if you can find it interesting. There is one position I'm going to talk in the next slide. There is an opening currently to get enrolled into this project. The other line on which we work is on using machine learning methods for flow control. This basically divides into 2 branches. On one side, if you want to control something, you need to get to know it. So we are working on techniques to perform sensing of the flow using few sensors. So you see there an example on estimating what happens far from a wall in a boundary layer when you have a measurement available at the wall. And we are doing activities there working with convolutional neural network and in general with deep learning architectures. And then another line is that, okay, once we know the flow, once we sense it, we want to control it. And there are many ways for doing that. One of the lines that is getting most attention recently is using the advances we have in machine learning to do these tasks. So we're working on genetic algorithms and on deep reinforcement learning to find strategies to get the flow doing what we want. Okay? So you see at the bottom right an example of a wake, the classical Karman wake behind the cylinder. And what you would get instead if you train a controller using reinforcement learning to kill that Karman wake, and in a way reduce the drag that is associated to vortex shedding. So this, in a way, kind of imitates what happens in nature, right? Like kids that learn with trial and error. That's the same that is done by reinforcement learning in a way. There is an agent which looks at the environment and learns how to act to modify that environment and obtain a certain task. Now, regarding openings, thanks. We have one opening now. Deadline is approaching, April 30. Actually, if you scan the QR code, you can get the full announcement in your access. Just briefly, the description, the task of this thesis is develop an aeroacoustic jet facility. So it has to be a jet with aeroacoustic quality. We are now in the process of building an anechoic chamber, and there is a part of development of a facility which removes all sorts of self-noise and gives us a jet that is sufficiently clean. Why we want to do that? Because then we want to develop strategies to control the noise and possibly reduce the noise signature the jet has. This is important in propulsion application, for instance. You know that part of the noise from aircraft depends on the jet. Another position that is possibly going to be open, depending on funding availability, probably in winter, is on drag reduction of road vehicles. Here, what we want to do is work on strategies based on machine learning to control the weight of heavy road vehicles, say in general falling categories of trucks and vans. Okay, so you see bottom right an example of a small van. We actually have one mounted in our tunnel, equipped with 4 jets, and those can be trained in a way to control what is the weight doing based on force measurements, of course on drag measurement, and on pressure measurement in specific points of the truck. Okay, so stay tuned on our webpage. You see the contacts on top of the slide. You can either get in touch with me or with Andrea Niro or Marco Raiola if you are interested in knowing what is coming forth. Otherwise, you can just go on the webpage of the Aerospace Engineering Research Group, and in the research area, you will find our lab. Okay?
Thank you. Thank you, Stefano. Here, another group studying the fluid dynamics, but this time from a computational perspective, is the one formed by Oscar and Manolo. Oscar is now in Seattle doing a full year a full year sabbatical research stay, and they do basically bio-inspired dynamics for micro air vehicles. So flapping wings. They are trying to to mimic what birds or small insects do in the nature. They also do turbulence. These 3 lines are more related with aeronautics, and they have another line in which they are simulating the fluid of cardiovascular fluid. And this is in collaboration with San Diego University. They have collaborations with Vienne, Karlsruhe, Maryland. They are not delivering here any specific PhD topic. Well, Manolo is up there, but if you're interested in these domains, so computational fluid dynamics, I'm sure you can touch base with Oscar and Manolo. You have the emails and show your interest. Anything to add, Manolo? Anything to add? Okay, sorry, but this is not my field of expertise, so I do my best. Andrea Cini.
You can do it. Okay. Thank you very much. Thank you very much, Manuel, for arranging this. I'll be very, very brief. I will keep my mask because I got a big nose, so that's better for you. So actually, joking aside, this is a small introduction of ASD Lab, that stands for Aeroelastic and Structural Design Group, run by my colleague Rauno Cavallaro over there and myself. And the idea is we're covering several different aspects of aeronautics, but in a way of fostering actually the disruptive technology revolution, we could say, that we are experiencing nowadays. So thinking about the green aviation and the reduction of environmental footprint of the aerospace, and this is actually required not just changing the powertrain architecture and reducing the pollution, but require a kind of disruptive changing of all the way we're doing aircraft design, airframe design, performance assessment, flight physics, and all these kind of things. So we try, let's say, combining different experience to try and, let's say, focus on this, on fostering and developing a kind of roadmap for all these kind of, let's say, new design methodologies, material, configurations, and technology, and see what actually is really required to, let's say, to implement that and to industrialize that. So these actually open a different kind of perspective for different PhD. As I said, we range from flight physics, aeroelasticity, airframe design, structure, manufacturing, fluid structure interaction, and all these kind of things, as you can see here. And we got, fortunately, we've been quite lucky to receive actually a couple of money during COVID. That was actually quite weird. And so we got several available PhD position now. Some of them are already covered. For instance, we just closed one about multidisciplinary design optimization, focus on investigating acoustic footprints of novel aircraft configuration, but there will be some others, in particular related to MDAO, multidisciplinary design, analysis, and optimization of hydrogen. Hydrogen actually is considered as a key technology enabler or key enabling technology for environmental footprint reduction. Therefore, is worth investigating. And actually, this is a typical example of what Manuel was saying before about the multidisciplinarity. My background is aircraft structure. I do structure, stress analysis, things like this, and I've been forced to investigate system engineering and try to understand aspects of thermofluid dynamics, combustion, and things like this. Of course, there are colleagues of mine that can do that better, but at least, say, you can see that any kind of different skills is more than welcome here. Then we got aerostructural and aeroelastic optimization of new generation flexible aircraft, where actually the flexibility, star counts, and the rigid aerodynamic cannot work any longer, and you need to consider all the coupling between fluid and structure, deformation and loads, and now actually you can combine everything into a systematic methodology that allow you to optimize your design. Then there is actually one available now. I think the deadline is by the 5th of May. And of course, you can go on the internet site of the university and on our LinkedIn to see and to gather more information about that. That is structural optimization methodology for sizing, design for manufacturing, design of certification of advanced composite structure. The problem is novel technology, novel structure require the showstopper most of the time is not the design process itself, is the certification and the manufacturing process and the operability of a structure. And this is actually allow us to gain some kind of weight saving from a technology, air structure and material, something well known, everybody knows that there are already composite made aircraft flying, the A350, for instance, but they are not optimized at all. They are designed as conventional black metal design, as a conventional aluminum aircraft. And this could be a real, let's say, opportunity to investigate a way of saving, maximizing, optimizing the structure, something that is well known, to allocate, to save weight for technology with lower TRL, like the powertrain, that are not, let's say, at high level of maturity. And then another one that is actually depends on if I'm securing a grant or not, that is fatigue and damage tolerance, certification and qualification method for primary structure additively manufactured. So the aspect of defect, fatigue analysis, and all this kind of thing. So thank you very much. I think.
Well, yeah, thank you. Thank you very much. So it's taking longer because we all are very passionate about what we do, so it's natural. Marta, I don't know if you want to come here or I go. Okay, so here is Marta with us. She works on composite materials applied to aerospace, to aircraft manufacturing, and she is looking for a PhD willing to do a thesis on additive fiber reinforced composites. I guess it's something experimental and eventually numerical, so it's combining both things. And here you have the email, and she will be here afterwards as well. Gonzalo just was out. Okay, so I go with Gonzalo's kind of two research lines. Gonzalo Sanchez, he does not have the email in the slides, but he's doing two different things. He's working on electrodynamic tethers. So kind of, you can see it here, right? It is a cable that generates a plasma and generates a force, and with it you can change the dynamics, or you can, for instance, eliminate space debris in the space, which is now an important problem. They got this FET Open project that is finishing now, and they have got an extension of it now, and he's going to offer a position related to electrodynamic tethers with mission analysis, so astrodynamics, and software development, and I guess also a bit of ground station control keeping and a bit of avionics, so a bit of hardware hands-on work. So you see that it's quite multidisciplinary, and this is going to be linked to this project. It will be opening, I guess, soon. The other research line he is leading the department has to do with airborne wind energy. So he's flying kites to generate energy. Tethers and kites are kind of linked with this tether. So this is a tether element as well. So you need to understand the cable dynamics and how to generate lift, drag, and how to extract energy. And he's working with a company in maturing the system, working on dynamics and control, and he's going to be, he intends to offer, because sometimes these intentions depend on securing a grant, but of course, if you are interested in this topic and you can also help in securing a scholarship, it would also work in that direction. But in any case, hardware, developing, flight testing, aeroelastic analysis. So again, experimental and numerical analysis. Manu, Sanjurjo, you want to come? Okay, so I repeat for those remote. This position will be opening in September 2022, October 2022. So it's for the fall semester of this year. So if you're interested, you can still contact. I think his email, well, he's Gonzalo Sánchez Arriaga, and you can check his profile in the PhD program under the supervisors. Okay. Here I try to do my best. So space transportation. So here, I guess, Manu Sanjurjo, you have his email, is doing stuff related to GNC, guidance, navigation of control of spaceships, finding the guidance law to do an orbit racing or an interplanetary mission, navigating, so understanding where you are with respect to that guidance scheme, that reference trajectory, and then the control, the real-time control in which you are modifying your trajectory according to the error, actuating in the spacecraft, right? So he was supervising a PhD with David Morante, and they developed this open source multi-objective optimization program for orbit racing, and the same for interplanetary mission. David Morante is now working in Deimos as an R&D engineer, so it's one of those examples in which PhD students jump to the industrial domain. And well, this is interplanetary. He does optical navigation with artificial intelligence. He's doing some control, model predictive control, to land in an asteroid or to do a rendezvous, and yeah, asteroid landing. So in the end, problems related to space exploration linked to GNC, guidance, navigation, and control, spacecraft dynamics, I would say. More or less correct? Okay. He's not offering anything in this research line, I guess, because he's supervising a bunch of theses, like 6 or 7 theses. He's very active in industrial PhDs because he has good links with GMV, Deimos, ENI. So probably in few years he will have new openings. And then the second research line he's leading has to do with space safety, space debris. That's a problem, as we have an environmental problem in our planet. There is another problem in space because some orbits, geostationary orbits, are quite crowded. So debris are expanding exponentially, and we need to take actions, right? So he's trying to build a catalog, try to understand how debris propagate, associated to uncertainties, try to working with ESA and with UMV in these activities. Even he was about to have a telescope with Russia, right? You had a project. So he has an institutional cooperation with Manuel Sánchez Piedra from Real Observatorio de la Armada, so the Spanish Army, on these type of things, and he's offering a PhD topic on stochasticity and chaos in astrodynamics, which is a broad topic, but very appealing, I would say. If you want to know a bit more details, I'm sure you can talk to him afterwards during the snacks. You want to say something, Manu? No? Okay. Okay. This is my activities. So I am pretty much involved in topics related to aircraft operations. So we have two main research lines, one on trajectory optimization, aircraft trajectory optimization, so atmospheric flight, incorporating or using optimal control, both analytical and numerical, incorporating uncertainties due to the atmospheric behavior, and building quite a lot of meta-heuristic algorithms. And I also have 4 ongoing PhD students in this activity. We are tackling the problem to understand how meteorology affects the trajectory, in principle safety and efficiency, and how can we reduce climate impact by modifying our trajectories. We are cooperating indeed with Rauno and Andrea in the design of a hydrogen aircraft and operation of the hydrogen aircraft towards minimizing climate impact. That's just an example. Then the other research line has to do with machine learning, neural networks applied to aviation. We apply it for predicting weather, predicting storms and other hazards affecting aviation. Also to understand capacity and demand imbalances in the network in terms of traffic, and also to predict climatic hotspots, right? So you see that we are somehow using sensors on the ground, on board satellites, on board aircraft to monitor a volcanic eruption, to monitor a storm, to see what's going on with contrails, and trying to capture data and learn out of the data, as Stefano was presenting before, right? I have a lot of collaborations with different institutions, universities, and even stakeholders, and I'm working in I would say too many projects. Hopefully they are ending already soon, and I will have more time to do real research. So what are we offering? Because we are offering mainly 2 PhD positions. Both are somehow depending on 2 grants that I have filed, I have submitted, and one has to do with aviation, artificial intelligence, and climate change. Building neural networks to anticipate where to find climatic hotspots so that aircraft aviation can avoid those areas. And the second is more at the airport level and has to do with deploying a network of sensors to monitor the atmosphere, pressure, winds, temperature, but also GNSS signal and other stuff, and being able to model the atmosphere to reduce the temporal and spatial resolution of the type of numerical weather products we have today, and with that being able to capture phenomena such as thunderstorms, wind shears, and others that are not being captured with today's resolution. So you see some examples of what we are doing here, and this is my email should you want to contact me. Another one, I think Javi is not with us today. Javi Garcia-Eras, we have here his email. He is trying to develop a research line on model-based system engineering applied to aviation, and he is working with Boeing and with a startup company as well, and trying to build this kind of double V model and trying to mimic the aviation system using a system engineering approach. So retrieving some sort of requirements on the one here, and then verifying that these requirements are fulfilled, building what we call a digital twin, which is also a hot topic. They want to build digital twins all around. Andres?
Vale. I didn't know that today we were going to be able not to have the mask, so I put a picture of me, even though you cannot see it, just to be able to recognize me on the outside. I'm also one of the, I believe, the latest academic staff to join the department. I started middle of last year, so I also put a little bit of a brief CV. I did my education all in the US, and I finished my PhD in 2004, and then I have a non-standard for Spanish approach career, because I have spent half of it in industry and half of it in academia, both in the US, UK, and Spain. So my technological domains is what is called robust modeling, analysis, and control techniques. In your degrees, you have studied the control by what is called the classical, and that typically uses just a linearized plan with fixed coefficients, so fixed numbers. But the reality of it is that most systems, the parameters change with time. So an aircraft or a satellite, as they operate, the mass gets consumed, so it changes the center of gravity and all these things. So for that, you need more advanced techniques, and that's my focus, the robust techniques for both, for everything, the modeling, the analysis, and the control. You also have faults and failures happening in the system, so you also need to apply techniques, which again, I apply the techniques for what is called fault detection, isolation, and fault tolerant control. So make the system resilient to these things, or capable of reducing gracefully the performance so that it doesn't lose the system or the mission. And you always need to verify and validate. Because of my industrial kind of legacy, I'm always very close to showing that you can apply these very advanced techniques into actual systems. Except for helicopters, I think I have touched most of the aerospace systems, so I've been involved in re-entry vehicles, observation missions, launcher and reusable launcher vehicles, exploration aircraft, and I have had the very extreme luck of flight testing things. So together with the German Aerospace Center, I flight tested some schemes in a vertical takeoff, vertical landing demonstrator vehicle that they have. I was able to fly also in DLR aircraft, some of my techniques, as well as in the Japanese agency aircraft, plus a couple of other things. I moved here from the University of Bristol. So we got hit by Brexit, then COVID, and then I decided to quit and come back to Spain. So I put my previous students and my current one. So Alice started with me a few years back in Bristol, and then she changed last year here to continue with me at the Carlos III. She's been funded by Airbus Germany, which is one of the satellite excellence centers of Airbus. And Thomas Ott will be coming here in a couple of weeks to give a seminar and do a progress meeting update with us. He's the head of the AOCS. So she already has presented at several conferences, and she actually got a Best PhD UK Automatic Control Association Poster Award in a PhD days that they organized over there. And my other students graduated while I was in Bristol, and they were funded either by European Space Agency or by the European Union. And these two were space, as well as Alison, and Andrea was more aeronautics. I put the number of journals that we produce to indicate one thing of the PhD. This is not the standard. This represents the high caliber of the PhDs that I was lucky enough, and in magenta is all the awards or nominations that we have. So this is your job as PhD students, which is to show the commitment. A PhD is not a 9-to-5 job. This is a lot of time that you have to fight against open questions that we don't know for sure if they are going to have an answer. It's also part of the commitment from us, the PhD advisor, because it takes a lot of time for us to support. And this is not classical, but it's my understanding coming from industry that as a PhD advisor, I'm there to help you maximize your potential, and I think that's true with most of the PhD and colleagues that we have. But certainly this amount of 4 journals, 10 journals, 9 journals, all coming from the PhD is because that the commitment from them, plus the very sweet spot that we have in developing very new techniques. So what do I have now? I do have already a project that I was awarded, so I'm looking for a PhD candidate for applying robust and machine learning techniques for system identification for aerospace system, focusing mostly in small satellites, CubeSat and up to 100 kilogram satellites. This could be potentially in collaboration with CENER and the University of Michigan in the States. I also have associated with this a postdoctoral researcher in verification and validation for AOCS, ADS, robust machine learning system. So as you see, repeated words because that's the project. This will be for 2.5 years, and I'm looking for them as soon as possible. The postdoctoral researcher, is the next step of the PhD. Manuel was saying that there are 3 main directions. You start a PhD because you want to continue in academia, because you want to go to industry. I did both. I went to, when I finished my PhD, I went to a postdoc, then I got a position at Delft, but I prefer to go to industry. So I went to industry, and then I went back to academia, and I'm here. So it gives you the PhD the possibility to do these 2 things, but pretty much the first step before this is having a postdoc, because it gives you a little bit more maturity. And in my opinion, this is the best time of your life. You still need to do a lot of work and publishing, but it's not the PhD that you have the Damocles sword hanging on you trying to finish, pressured by your advisor, and it's not that you start a position in academia where you have administration and teaching, or in industry where you have to produce things. The postdoc is actually where all that you did in your PhD, you start to making it give you credit and start producing. So I will encourage to do a postdoc. So I put this position as well in case some of you are close to finishing and you are interested in control to come here. And then as Manuel said, the last one is pending a proposal that we submitted. We should hear in June. This will be a European project, and what we will be doing is trying to come up with a demonstrator for agile and stability of satellites for the AOCS. And this will be together with the Center for Satellites that we are building here at the university, driven by the department, and we will hear in June. So the idea will be to start towards the last part of the year, if we get it. So I think that's all from my side. Yeah. Thank you very much.
Thank you, Andres. Mario, I don't know, how are we doing with time? Well, not bad, yeah?
I will try to be brief.
Yeah, because, yeah.
Okay, well, hello everyone, and thanks Manuel for organizing all this. Since you are probably already overwhelmed by so many presentations and so many ideas of possible PhDs, I want to be very brief, okay? So, questions? No. Okay, well, I will show you a little bit about our research group and the activities that we have ongoing, and some of the ideas on which we want to open PhD positions soon, all right? So this is our group. We are essentially the only group in Spain dedicated to the research of plasma space propulsion. That is how you move your spacecraft without using chemical reactions, all right? Plasma thrusters, if you are not aware of them, are already flying, and they are very successful in that they use about 10% of the propellant that the chemical rocket would use, all right? And that makes them the preferred choice for many missions. About 1/3 of the space systems in orbit already use them, and the forecast is that this is going to grow exponentially in the coming years. Okay, so this is a field with a lot of promise in the future. We are a group that is well established. Okay, we have a long trajectory. We are relatively large. We have about 20 researchers. Okay, there is Eduardo Aedo, who is the full professor, then Pablo Fajardo, Jaume Navarro, and myself, and then postdocs and a lot of PhD students as well. All right. And here you see a couple of pictures of our thrusters in our chambers. I wanted to include this slide to show you that we are involved in a number of projects. Most of them are European projects, and I think this is a relatively interesting aspect for prospect PhD students. If you come to our group, you can get involved in European projects or other projects, national, regional projects. And this is great because you get to collaborate with other institutions, all right? We are in contact with essentially all of the researchers in Europe and industry as well, dedicated to plasma propulsion, okay? And I think this is a great advantage of doing a PhD in this area. Well, next I just wanted to show you some examples of the type of things that we do. Okay, sorry that the slides got a little bit broken on the top. So this is an example of one of the lines that we have ongoing since a long time. This is the simulation of Hall effect thrusters, which is a particular type of plasma thruster. And as you can see, there are some oscillations that are ongoing during the discharge. Okay, what you see is basically the channel of the thruster. This is the plane of symmetry, the axis of symmetry. Okay, so this is actually an annular shaped thruster. And this is done by using advanced numerical codes that simulate the ions and the electrons in the plasma with particles. Okay, so it's a particle code. Actually, it's a little bit more complicated than that. It's a hybrid code where the heavy species, ions and neutrals, are modeled as particles and the electrons are modeled as a fluid. Well, never mind. We also do, with this type of approach, the simulation of 3D plasma plume expansions and the interactions of these plumes with the surrounding spacecraft, which is a very important topic for satellite integrators. If you want to fly one of these thrusters, you need to make sure that the plasma is not going to impinge on the solar arrays, for example. We also do modeling of other devices. Here you see a collection of simulation results. For example, we have the ECR thruster, which is a novel device. This is an example of a collaboration. This actually was done in ONERA, okay? And we simulated it, and we obtained the maps of the different properties of the plasma. We also have helicon thrusters. This one is built in-house, okay? And we also simulate the internal physics and the external expansion in what we call the magnetic nozzle, okay? Essentially, we have Navier-Stokes equations, but we deem that they are too simple, and we include the Lorentz forces on them to make them more interesting. Okay, so this is basically what the plasma is. We also simulate the electromagnetic waves propagating in the plasma, which is also a very interesting problem that affects the behavior of these devices. Next, we have the laboratory. Okay, so since more or less 5 or 6 years ago, we started with our own research laboratories, essentially the work of Jaume Navarro over here. And we have been developing different types of devices. First, we have the helicon thruster, which I mentioned before. This is a collaboration with Sener, aerospace company here in Spain. Then we have other devices like a novel Hall thruster. This over here is the helicon thruster again. This is an ECR thruster, okay? And this is a novel concept that we are developing in the framework of our ERC Zarathustra project. Okay, and this is, well, a collection of open topics, okay? We are always looking for good candidates. I will mention in the next slide what we are looking for exactly. But in essence, we are interested in everything that has to do with modeling and simulation, and everything that has to do with experimental work in the lab. Okay, so the top lines over here are essentially modeling, okay, modeling in magnetic nozzles, the external expansion in the magnetized plasma. We want to see the stability, the collisional effects, the magnetization, induced field aspects. These are ongoing lines, okay, so you wouldn't be building from scratch, you would be developing on things that are already ongoing. We are also very interested in continuing the numerical simulation of the magnetic arc thruster, which is the Zarathustra thruster I mentioned before. We are also delving now into data-driven techniques, okay, to try to understand better the physics of the plasmas. And we, well, okay, I included a long list. I'm not going to read it all. If you are interested in doing anything on plasma thrusters, best is to contact us. You have our contact in the EP2 website, so you can find us there, and of course you can ask us anytime, and we can orient you also to see if this is something for you. What are we looking for? And I think this is essentially applicable to all other PhD offers that you have seen before me. Essentially, we want to have students with a great academic record. If you want to dedicate yourself to research, you need to have a very robust and solid background on physics, mathematics, and other areas, okay? Of course, you have to be also a responsible person, autonomous, as well as a team player. You will be working alone, but you will working in a team. In our case, we basically distinguish two different types of PhDs. Okay, so those dedicated to modeling and numerical simulation, we are looking for people that are good at programming. They like computers. They enjoy getting into those type of problems. When we talk about experimental work, we need a hands-on person that is good at designing, okay, solving procurement problems, building, testing, etc. So that's it. I hope that I got you an idea of what we do. Thank you, Manuel.
Thank you, Mario. Thank you very much. So, thank you. It was a bit of miscellaneous presentation here and there, different people. Sorry if it was not very fluent, but I think you all got a picture of what we're doing. We have thrown at least 8, 10, 12 PhD opportunities, some of them open today, some of them that are going to be open soon, potential opportunities. And again, if you are willing to do a PhD and you meet some of those kind of requirements or skills that Mario was pointing out, there might be others, okay? But especially if you have the motivation, if you have the interest, if you feel the passion, that's the most important, I would say. And you want to do a PhD, identify what you like, what you feel inspired by, get in touch with the supervisor, potential supervisor, and try to jointly explore the opportunities, because funding, you might find it, but most of the times you need to look for it, right? This is my recommendation. Now, we all want to reach to lunch, but give me 5 minutes, okay? I want to now talk a little bit about industrial doctorates and institutional cooperations, which is also very important. It's something we really need to strengthen, because this is one of the objectives of the PhD program. In the end, we are feeding the industrial agents. We are also somehow cooperating with our research institutions. We need to make Madrid region, Spain, Europe competitive, and we need to add value in the space domain to keep doing research and eventually competing with others and improving the quality of life of the people, right? We currently have 7 industrial PhDs, people working at different companies. We have Deimos. This is a student with a Marie Curie scholarship, so-called ITN network, that is working with Manuel Sanjurjo on space-related topics. Manuel Sanjurjo is also supervising a student working at GMV on, I believe, space debris, right? And this is because Manuel has strong relationships with these 2 companies, and they are going together in different calls that the Madrid region and at a national level we have for public-private kind of initiatives. GNI is the startup I was mentioning. They do micropropulsion for CubeSats. And they have 3 industrial PhDs with us, right? You can check the website. They are very active in LinkedIn, and you can see what they are doing. And indeed, they just hire a former PhD of myself for the team. And they do, again, as Mario was saying, they do modeling, numerical simulation, but they also do hands-on work, because in the end, you need to manufacture things, to do hardware. And when you are maturing research, the natural evolution is to move from the paper, from fundamentals to the computer, and then to the lab. And then you would do what Andres was mentioning, right? Verifying, testing, certifying, etc. This is CENER, 2 students with CENER. One is linked to Jaume's work in the laboratory for a lot of years on a new or brand new plasma thruster, Helicon thruster. Correct me if I'm wrong. They are built into it, and the other one is working with Gonzalo. This one is under a non-disclosure agreement, because sometimes when it comes to industrial PhDs, you have non-disclosure agreements, and it's something that we can also, of course, admit. and everything is confidential. In any case, you see that all of them are working in the space domain. So when it comes to aeronautics, we need to make an effort to strengthen our cooperation, our collaborations with aeronautical domain. Probably there is a bit of philosophy, a bit of legacy in the way space and aeronautics has been developed. But we need to work on this. And when it comes to institutional cooperations, we have a PhD, also Manuel Sanjurjo is supervising, well, these three indeed. So cooperation with ESA. We have our first student working at INTA, the National Center of Aerospace Research in Spain, and we want to strengthen that, and I will be commenting a couple of things afterwards. And we also have an agreement with, PhD ongoing with the Army. When it comes to observing the Earth and space debris. So what can you do if you are working for an industry or you want to do an industrial PhD because you don't feel like spending 4 years in the academic domain? You can go to a company and you can talk to your boss, to your team, and express your interest in doing a PhD. When it comes to industrial PhD, you first need to talk to your colleagues at the company, and you need to understand, you need to know that there are possibilities to do an industrial PhD with us, right? There is this program, Industrial Doctorates, by Comunidad de Madrid. It is in Spanish, sorry, but basically this is supposed to come up very soon because it was expected during the first term. And this provides an opportunity to file or submit a proposal between a company and an academic institution. And you at the company, you get a grant. I think it's covering half of the salary or 70% of the salary, something like that. But we also get money to pay trips, to pay a computer, to pay research stays, and to establish a collaboration, even to hire other people so that we establish a team that works together. Of course, at the company level, they need to be aligned. They need to be doing real R&D. They will get our knowledge. They will get a highly skilled and trained employee for the future. They will open up new research activities, new ideas, new approaches to tackling a problem, because this is important when you do a PhD, right? A new way of thinking, of approaching a problem. And I strongly encourage you to touch base with us if you're in a company, to show your interest so that we, supervisors, together with you, a potential PhD student, and your boss at the company, can build a proposal and start collaborating. Always frame in our strategic ideas, in our strategic lines. We are presenting you what we are doing because, as you might imagine, we cannot do something completely different, right? So it needs to be somehow aligned, but I'm sure there are a lot of topics that might fit within the interest of different industries. Another opportunity has to do with the doctorados industriales, industrial doctorates, offered by the Ministry of Science. This was closed on February, but it comes every year within a plan, and it's similar, it works in a similar manner. So there are instruments out there to look for help, for funding opportunities to do these industrial PhDs. If we go into a European level, there may be other opportunities, but the most relevant one are the Marie Curie actions, especially the doctoral networks. For this, you need to build a proposal, a European proposal, between academic institutions, companies, and within that proposal, you get what they call early stage researchers. So you hire an individual to do a PhD at the industry, and also here at the university. Now, well, by the way, there is no formal difference between an industrial PhD and an academic PhD. The title is the same. The conditions are the same. The only thing that changes is that you are developing your research either in the academic domain at the university or hired by the industry. But we should cooperate, we should establish ways of working in which an industrial PhD can come here once per week, or maybe once every 2 weeks, can spend here some time, and somehow, you know, cooperate in a fruitful research activity. When it comes to institutional cooperations, I would like to just highlight, we are open, of course, to host PhD students developing research in CSIC, the Scientific Institute of Spain, or IMDEAS, or other type of scientific centers. We are very much interested into INTA because it's the Aerospace Research Center. And indeed, they offered 25 positions last December. We had a colleague, Andoni Moral, presenting the ExoMars mission and 2 PhD openings. Some of them were covered, but some others were not covered. And they might be relaunched soon, May, June. So pay attention. We will try to broadcast the information, because I know that for them it's difficult to get people interested in doing a PhD. And in this case, you would be entering in a public institution with a PhD grant contract, but the opportunity to continue on and develop a career in INTA, at INTA, is likely, right? So I think it's a good opportunity, and they are doing a lot of interesting things. For instance, here I have one opening. I don't know, Gomez, Luis, I don't remember the name, sorry. Miguel, sorry. So here is his email. We have, by the way, Rodrigo with us. Rodrigo is a PhD student that now works at INTA. And there is another one, Carlos, that is already a PhD and is a principal scientist at INTA. So they are trying to also, together with Stefano, Andrea, to develop a research line at INTA. So you can talk to him. And here you have navigation, guidance, navigation, and control. GNSS devices. Well, I am not going to describe this. But basically, if you're interested in doing a PhD on these topics, here is the email. We will be posting this in our webs. And we want to strengthen our collaboration with INTA for sure. We will be doing a visit soon to check the research facilities, see if we can collaborate, get to know the people, and see if we can further collaborate. And with this, we are done. I would like, before finalizing, I would like to thank Maria, who is there, for putting together all this, organizing the web, the post, the lunch. So thank you very much. And well, I don't know if you have questions or not. If there is anything specific that all those video on the screen should listen to, just should pose the question. If not, we can go together, take some snacks, some beers, and we are all there for you to discuss anything. So, is there any question by anyone? No? Okay, so I would like to thank you all for being here, also those beyond the screens. We will be publishing the video recording, and also wrapping up the PhD positions so that you can see them in the web, and eventually you can apply for them. Thank you very much. Enjoy the day.